Lesson 81, solving inequalities with variables on both sides. So we're going to just start with an example of an inequality. Whoops, we'll just do example 1 with a z contained on both sides. Plus 1 minus 8z is greater than 3 minus 2z plus 4. So this is our given. Now we're going to combine like terms first. Okay, so on the left side of the inequality we have a 4z minus 8z. Those are like terms. 4 minus 8 is a negative 4z plus 1. Greater than, on the right side, we have a 3 plus 4, which is 7 minus 2z. Now, what I would like to do is add 2z to both sides and subtract 1. That way I get all my z's on the left side and all my constants on the right side. So I'm going to do plus 2z. And then I'm going to subtract the 1. Now when I do that, I'm left with negative 2z is greater than 7 minus 1 is 6. Now in an inequality, when you divide by a negative 2, a negative number, you have to flip the sign. So we're going to have a less than sign. So z is less than negative 3. So what did we do here? We used the addition and subtraction property of equality. And then we simplified. Then we used the division property of equality. We switched the sign because we divided by negative. And then we simplified. Now, if we want to graph this, we need to have a negative 3 on our line. We'll go down a couple. Oh, that's going up. Negative 4, negative 5 will go up a couple, big open circle on negative 3, and then pick numbers that fit into here, any number below negative 3, so we make that arrow nice and big and chunky. There we go. Now sometimes there are some special cases. So let's say that we are solving for our inequality and we get something that's sometimes true. So that's pretty normal. That's what we normally are doing. Just like we did here, z is less than negative 3. So that's sometimes true. If you had one bigger, it wouldn't work. So this is what we're looking for. It's going to have a solution set. That's our normal type. Now sometimes we'll have always true. And that's if you are, if you graph something, if you get an inequality where say 1 is greater than negative 10, that's going to be always true. And that's called an identity. And then sometimes we'll have ones that are never true. And an example of an inequality that's never true is if you had 0 is greater than 10. That's not ever going to be true. So I'm going to give you some, and that's called a contradiction. So always true is called an identity, and never true is called a contradiction. The solution to an identity is all real numbers. Whoops, we don't need an arrow there. We'll just put solution is all real numbers. So if you graphed it on a number line, you just make the whole number line solid. Contradiction, the solution is basically no solution. There won't be a solution at all. So I just want to give you some examples of those special cases. Oops, we're going to call this example 2. 2x plus 1 plus 2x is greater than 4x plus 10. So we combine like terms. We have 4x plus 1 is greater than 4x plus 10. We're going to subtract 4x from both sides. We want to get those all on one side. And we have 1 is greater than 10. Well, that's never true, so it's called a contradiction, and the solution is no solution. So when you're finding the solution, that's what you want to write. It's never true, never true. Okay, here's another example. If we have 2y plus 3 minus 2y is less than negative 7y plus 9 plus 7y. So if we combine like terms, 2y minus 2y is just 0y, so we have 3 is less than. Negative 7y plus 7y is 0y plus 9 is 9. So 3 is less than 9. This is always true. We call this an identity. The solution, oops, not identity. Okay, so the solution is all real numbers. That's what our solution is. And if we wanted to graph it, we're going to draw a number line. We're going to color it in really solid and put arrows on both sides. There we go. And that's the end of the lesson.